Hey everyone, so welcome to my second and the last lecture on a tribute to Professor Kaprekar. So, as of now, this is the last lecture. In future, if the need arise, I may come up with some more lectures on his work. Okay, so in the last talk, we saw about Kaprekar's constant. If you missed somehow, don't worry, I will post the link in the description so that you can have a look. Okay, so what are Harshad numbers? So he gave these numbers, such kind of numbers as Harshad numbers because it's a Sanskrit word. Harsha means joy and Da means give. So like they were the joy giver numbers. So that's why Harshad numbers. In literature, they are also sometimes called as Niven numbers because Ivan Niven was the one who delivered a paper at a conference in number theory in 1977. And they are also called as multi-digital numbers. Let's see what are Harshad numbers. You take any digit and you take the sum of the digits. If the sum of the digits divide your number, then such numbers are called as Harshad numbers. Or the taken number is congruent to 0 modulo the sum of the digits. Then such numbers are called as Harshad numbers. Like if you're a number theorist or the one who works in cryptography, they usually refer this language that given number x, if it is congruent to 0 modulo the sum of the digits. This means when x is divided by the sum of the digits, the remainder is 0. So this is what the language used by modular arithmetic people or the number theory people. Okay, so let me take some examples so that the concept become clear. So if I take the number 2020, then what is the sum of the digits? 2 plus 0 plus 2 plus 0, which is nothing but 4. And does the 4 divides 2020? Yes, it do divides. So the remainder is 0 when you divide 2020 by 4. So yes, it's a Harshad number. Ramanujan number. Is a Ramanujan number a Harshad number? Yes, because the sum is what 19 and 19 do divide 1729. And if you don't trust me, you can definitely check with the calculator. Let's take 37. Okay, prime number. Is this a Harshad number? No, right? Because when I do 3 plus 7, what I get 10 and 10 does not divide 37, so it's not a Harshad number. What about Kaprekar's constant? Is this a Harshad number? You take the sum of the digits, which is nothing but 18, and just check whether 18 divides 6174 or not. If 18 divides 6174, then yes, it's a Harshad number. So just tell me in the comment section whether the Kaprekar's constant is a Harshad number or not. So I hope the concept is clear now. What are Harshad numbers? Well, then in 2005, Bloem came up with the concept of multiple Harshad number. So what he invented this terminology, and what he said is, you take a number, you divide by the sum of the digits. Whatever the quotient you get, if that quotient is again a Harshad number, then such a numbers are called as a multiple Harshad number. Let me take an example so that this thing will be clear. So if I take 6804, what is the sum of the digit? It is 18. Well, 18 divides 6804. Yes, 18 into 378 is 6804. That means what? The remainder is 0. So therefore 6804 is a Harshad number. Now what is the quotient? Quotient is 378. So is 378 a Harshad number? Yes, because when I divide 378 by the sum of the digits, what I get is 21. This is the quotient I am saying. Remainder is 0. So 378 is again a Harshad number. What about 21? Yes, 21 is again a Harshad number because 21 is divisible by the sum of the digits. And then we get 7, and 7 is also a Harshad number because it is divisible by 7. So 6804 is called as MHN 4. Why? Because till 4 iteration we were getting Harshad number, like 6804 is a Harshad number, 378, 21 and 7. So all these 4 are Harshad number, therefore it is also called as MHN 4. So now here is some more homework for you. So just check whether, so what is 915? So it's a Harshad number. Just see what MHN it is, like till how much iterations you will keep on getting Harshad numbers. 910, 17, 119. And if these are very easy for you, then try for this. This is a huge number. So one thing is you can do the things manually, but if you know coding like Python or C or whichever language is good, you just write down a small code, like write a for loop, and you can just see till how many iterations you are getting a Harshad number. It's a simple loop which if you write, you will get answer in one click. So my suggestion will be to write a code, and if you can try to just post in the comment section, or you can do manually as well. So just tell me how many MHN are this. So next is the Harshad numbers in any base system. So when I delivered the first talk on Kaprekar's work, 2-3 students from computer engineering, they asked me, what about Kaprekar's constant in any base system? So this time I thought of including this one more slide. So like what we do is we deal with the decimal number system or base 10. So instead of giving you the precise definition over here, let me directly take an example so that the things will be much more clear, because my aim is that even a person with not deep mathematical background should be able to understand my lectures. So but those who are interested, they can just Google Harshad numbers and you just go to the Wikipedia page, you get a proper definition, mathematical definition. Let's take an example. Take the number 12. Now see, in base 10, so what is this 12? This 12 is nothing but this coefficients 1 and 2. These are nothing but that coefficients, and this 10 is nothing but my base system. So since 12 can be written as 1 into 10 raised to 1 plus 2 into 10 raised to 0, so this coefficients is written over here. That is what this express means. They are nothing but the coefficients. Now what are Harshad numbers? You sum up these coefficients. Now if that sum of the coefficients divides the number 12, then I will call it as a Harshad number in that base system. So now here number is 12. Is 12 divisible by the sum of the coefficients? Yes. So therefore 12 is a Harshad number in base 10. Okay, so that was easy. Let's go to base 2. Base 2 means binary. Now how can you express your 12 in binary form? So you can see your 12 is nothing but 1 into 2 cube plus 1 into 2 square plus 0 into 2 plus 0 into 2 raised to 0. So if you observe, the powers of 2 are decreasing over here, and what we take is we take the coefficients. So here the coefficients are 1, 1, 0 and 0. So 1, 1, 0, 0 are the coefficients, is the coefficient. So base 12 is expressed as 1, 1, 0, 0 in base 2. Now what are the sum of the coefficients? It is 1 plus 1 plus 0 plus 0, which is 2, and 2 divides 12. So yes, it's a Harshad number. Let's go to base 3. In base 3, you can write 12 as 1 into 3 square plus 1 into 3 plus 0 into, oops, it has to be 3 raised to 0, but yeah, anyway, so that's 3 raised to 0. So what you get is 9 plus 3 is 12, and what are the coefficients? 1, 1 and 0, and therefore you get 1 plus 1 plus 0 is nothing but 3, and yes, 3 divides 12, so it's again a Harshad number in base 3 as well. In base 8, 12 is nothing but 14. How come? Because 12 is nothing but 1 into 8 raised to 1 plus 4 into 8 raised to 0. So therefore 12 in base 8 is expressed as 14, and what is the sum of the coefficient? Is nothing but 5, and 5 does not divide 12. So therefore 12 is not a Harshad number in base 8. So you take any number. So for example, you can take number 15. You try to write, so like in decimal system, 15 means 5 plus 1, and 6 does not divide 15, so it's not a Harshad number in base 10. Try to write down in base 2, base 3, base 4 or base 10 or base 11 or base 12, whichever base you like. Write down 15 in that base and just see if it's a Harshad number or not. If you don't know how to express in a specific base system, simply go to the Google and just write down simply type it out, base calculator, convert base calculator, and you have a calculator. You simply enter 15 and select the base you want. It will automatically get converted, and then once you have the base system representation, you simply add up the coefficients and just see whether it divides or not. So that's how Harshad numbers can be generalized to any base system. So 12 is a Harshad number in base 10, base 2, base 3, but not in base 8. So take any good number if you wish and just try out one small exercise. And at the end, I would like to just conclude my lecture by saying what are all Harshad numbers. So number which is Harshad number in each and every base system, then such numbers are called as Harshad numbers, and there are only finitely many, 1, 2, 4, 6. These are the only 4 numbers which are Harshad number in any base system, whereas 12 is Harshad number in all bases except octal, and that's what we saw here, right? 12 is not Harshad number in base 8 octal. Whereas if you take any other number, it is not Harshad number in one of the bases. So that is the concept of all Harshad number. So I hope you like this video about Harshad numbers. Make sure you like and subscribe to my channel, and if you really liked the video, then make sure to share the video as well. Thank you.